Welcome to Unit 17 Jump Game Level 1. This is an extension of the Level 0 program. We're going to add a lot more interactivity with this, with some moving platforms and some obstacles that move around on the screen. We'll reuse some of the triggers that we've seen before with some hidden sprites to add some excitement. So we're kind of building out a full-blown game here. Let's pull it up on Scratch, and it might run slow because this video capturing software tends to eat up quite a bit of the processor on my computer, since I'm kind of using an older machine here. Let's see. I might have to drag and drop this because it's run slow. Yeah, let me do that. Let me pause it, and let me tell my ghost on the sprite here. I'm going to set it to 1, so we should, there it is. Okay, I'm going to drag it up here so we can go through the levels a little bit faster. You can do the same thing when you're testing your program out. Just makes it a little bit easier. Now these are the first same levels from the other jump game. You'll notice I don't drag and drop it on top of the door. I guess I could, and it'll work just fine. Okay, here we go. So we got some moving platforms here, and you can see that whenever I get my sprite moving, and now it seems to be running fine. So you can jump on the platform, and you'll notice that we're able to have our sprite actually move along with the platform. Oh, I died. That's not what I wanted to do. Alright, so what I'm going to do is I'm going to turn off this as well. Okay, you'll see all that in your, actually you've already made that part of your code. So let's get this situated so you can go through and see the whole program. It would take too long for me to play out the entire game. And not to mention, it's a little bit tricky, so I don't want to keep dying and making this video super long. Okay, so you can see the platforms, and oh, come on, mouse. So if I put my guy here on the platform, you'll notice it moves up and down with it. Oh no, come back. Ah. Oh, that's right, I told you not to die. Okay, we'll drop it right there. Okay, so we have more moving platforms, kind of same scenario. My door, where did I have my door? Oh, there's the door. Drop it off there. Then we got this sprite that swings around here. And let me move it right here. Is this the level that has the, there it is. We got some random sprite that shows up on the screen that's trying to kill you. We got a spinner obstacle here. And I don't think there's another triggered sprite right here. Nope, there's not. We go to the next level. Then we got some obstacles that are flying up and down in the air. Not the best graphics for motion of falling. And here we got another sprite that randomly appears on the screen that chases you down, and then we actually make it fall down with you, so adds a little bit of excitement to it. And then we move our sprite up here. You gotta time it so you run through this part, avoid that spinner and the rocks, and fall down onto this part. And then here's where it gets kind of crazy, is I actually make the lava rise up. So you gotta time it, avoiding the rocks, jumping down to this moving platform to get across and up before the lava actually hits you. And on top of that, I have a sprite here that's kind of a trap door that will trick you into falling into lava. So we got a lot of different things going on. Whoops, didn't grab that correct sprite. Oh, I didn't beat the timer even when I was cheating. So you can imagine it's pretty hard. You can adjust the code to make the game easier or more difficult as you see fit. Alright, let's go to the presentation. Okay, so we're going to look at how to make interactive moving platforms, some more of the triggers, debugging strategies, and how to handle conditional logic errors within the program. Okay, so first off, debugging. This is a huge skill you'll need for programming whenever you start making some advanced programs or even simple programs. You'll be shocked that a simple program could have a huge bug in it that could set you back a tremendous amount of time. So Scratch is pretty cool because it eliminates a lot of the errors that we would have with creating code, which is good, but it's also bad because Scratch will also take poor code and make it run because it doesn't really care. So it's a kind of a double-edged sword there. One, it helps eliminate debugging errors, but also it allows errors to take place, and it may cause your games to run a little bit weird. Okay. The definition of debugging is the ability to locate and fix errors when programming or any computing technology. And debugging crosses not just programming, but any sort of technical endeavor, or I guess anything in life in general. Now, when you debug, there's 4 steps to go through. 1, you got to identify the error. 2, find the error. 3, analyze and fix the errors. And then 4, check for side effects. You follow those 4 steps for debugging, you're going to be just fine. Okay, so ID the error. What's causing this problem? Why, for example, does my sprite keep falling through the walls? Okay, all right, so find the error. Let's go through the code and locate the part of the script that's supposed to control the collision between the sprite and the walls. Then 3, analyze and fix the error, and check out the script and say, okay, what could be causing the script to not work? Like, it should work, it seems to work, but what's causing it not to work? You can go through and troubleshoot, mix and match, play around with it, see if you can find a solution. And once you find that solution, see if there's any sort of other side effects there. You might create a solution that could cause other things to go wrong. Let's see, debugging part 2.2. This is called a logical error. And these are the worst because it's a problem with the script that has been programmed by the programmer. Those are going to be the most common errors you have with Scratch, and they're the worst because, like I was telling you, with Scratch the programs will keep running with a logical error, and you may not get any sort of help on finding where the error is. If you do advanced programming like with Java or C#, you have logical errors. Again, you have the same scenario where the program runs, but it's not run the way you think, and you're going to have to go through and isolate the location where the error is, and that could take a lot of time and could cause you to have a headache. One strategy with Scratch is use the say or think blocks inside your script. You saw that when we did the Micro Eraser GT level 1. We used those blocks to help us find logical errors when the sprite was turning. Okay. After creating a function, you can also double click on the hat block of the function to test it out individually. That's a good way to see if it actually works. Now, if it's code dependent on other items in the program, you got to keep that in mind. Again, test single pieces of your code to see if they work. Next one, display the variable information while you program. Make sure you have the variable information up. Sometimes it'll get cluttered, so try to isolate just which variables you'll need the most whenever you're putting that information on there. Next, you want to use the sound and other signals to strategically place within your code to notify when something takes place. Okay, so just having sounds and other colors changing or something like that, it's going to help you identify where there's errors. Okay, and make sure you stay organized and name your sprites appropriately so you can identify the locations of where those are. So it will help you identify what could be causing potential error. And then last but not least, make sure you maintain your patience. Don't lose your patience. If you get frustrated, go get a drink of water, go do some push-ups or something, and figure out a way to keep yourself under control. Okay, here's some common debugging scenarios that you might run into. For example, you have 2 broadcast messages, all right, and one thing you need to check out, if your message is not activating once it receives the message, make sure they have the same message name, okay? Or the variables may be misspelled. You can notice right here, this capital M in message 1 and lowercase m in message 1, those are 2 separate messages. Whoever made this, well, it was me, just for the record. But let's pretend it was a student, and let's tell that student that, hey, you know what? You don't duplicate message names and then change them and try to use them in the same capacity. Keep the same message name that you plan on using throughout the program. Okay, you don't have to make a new message name for everything, so don't confuse yourself. Stay organized. Same thing with variable down here. 1, we got a generic name called variable. 2, one has a lowercase v and the other one has an uppercase v. Okay, those are really simple mistakes that can cause a lot of headaches. Graphic problems, okay? Part of your program could have a lot of issues because the graphics, there could be certain colors, especially what we've been doing with these more entry-level programs. We've been looking for color detections to initiate our collisions. Okay, so those color detections could cause a severe problem because some sprites you're using have embedded pixels in them that might have an RGB value that matches up with the RGB value of the color that you're trying to detect for the collision. And that's a big nerd way of saying that your sprite may have a little block of color hidden inside of it that matches the color of the other object that you're trying to detect in its color, and that could cause some sort of error with that. Plus your graphics may not be centered correctly, or there may be hidden pixels around the border of the screen where you thought was transparency. Some common issues: center of the image is not in the correct location. I just said that. Parts of the image are not actually transparent. I just said that. There you go. Single pixel could be hiding somewhere in the area you thought was transparent. The dimensions of the image may not be correct for how you want the sprite to be positioned on the screen. When using color detection, I just said that one, so I'll let you pause it and read about that. Okay, our moving platforms here. So the moving platforms, what you'll see is our sensor will touch the platform, and that's this little black rectangle here with the green line in the middle. And when the red is touching black, just like in the previous jump game, when red is touching black, that's telling our sensor that it can no longer go down because it's actually touching a object that it wants to collide with. And once it's touching that, you can come over here and see, okay, when red's touching black, we check to see if it's touching mover 1. That's the name of the sprite right here. If that's true, next we go into this if condition. We're going to check to make sure the left arrow key is not pressed, and we're also going to check, or we're going to check to see if the right arrow key is not pressed. If neither left or right arrow key is pressed, we'll change the X position of the sensor sprite right here by a variable called mover1. And mover1 is a variable that we set up in the code that tells the mover sprite how fast to move. So long story short, the sensor sprite will end up changing its X position by the same exact value that we changed the mover position. That's what causes it to look like it's sitting on there and actually moving at the same speed. Down here, we also say, okay, if the orange color is touching black, we set X velocity 1, and if the blue is touching black, we're going to set X velocity to -1. So that way we can stop our player from jumping into the side of an object. So if we are jumping up and we hit it with the side, this will stop the player from actually moving in there because it will cause it to bounce off. Okay, that pretty much wraps it up with the moving platforms. And last note, over here on the vertical for the sensor, it does the same exact thing. So if the sprite's moving up and down, or the platform's moving up down and we're touching it, what we'll do is we'll tell the program to change the Y position by this value. And then we'll also, we're not going to worry so much about the left and right arrow keys since it's going up and down. So that way we'll just automatically change its Y value no matter what, even if it is moving left or down, because technically if it's moving up, and even if your character is moving left, the sprite will get pushed up because the platform is moving up. Okay, let's go to the next slide here. The obstacles, we got a rock. We're going to use that in levels 9 and 10. It's just going to fly them down. The code's okay for this. I wouldn't go out and try to publish something like this trying to make a game. The main goal is just to get some variation of the game with something flying up into the screen. We probably could have programmed it a little bit better so there's more of a feeling of velocity and acceleration and deceleration with the rock. I'll let you go back through and do all those type of things to make it a little bit more exciting when it flies up to the screen. My main goal was to get a sprite that appeared on these levels, and it was randomly selected to come from the bottom of the screen from a random X location. And then it's always going to go up to a random Y and come back down to the equal location where it started. My other goal was to create some sort of hidden object. I call this the roller, and it starts on levels 8 and 9. And what it does is it uses a trigger that's hidden inside the game. And when your player touches the trigger, just like the escape, it's going to cause that roller to come after you. Then the spinners, these are basically just a solid costume. So if you look at the spinner costume, this is all one sprite right here, okay? There's not more than one object. and it appears on these levels, and basically we just tell it to rotate and turn around on its costume center. Nothing super complex. And then the lava is just a gigantic red sprite, and I tell it to glide up and to glide down over a certain amount of time. That's all it does, and it's the same color that would cause your player to get hurt. Okay, and that wraps it up for the Jump Game Level 1. These are all the sprites you will need, plus the stage. You'll be programming all these items. Make sure you walk through the code, pay attention to detail as you do these items. Most of the things you've seen in here are not new to you. The only thing you might see that's different is the mover 1 and mover 2, and it's nothing super different than what you've done before. It's just kind of a continuation and adjustment of previous code that you've already learned. All right, good luck, and we'll see you in the next video.